స్టార్ట్ చేద్దాం. టైం అయింది. తర్వాత
స్టూడెంట్ పార్టిసిపెంట్స్ ఓకే స్టూడెంట్స్ ఎవరైనా వస్తారా ఇంకా వెయిట్
దట్స్ ఓకే అంటే యూ ఇంట్రడ్యూస్ అండ్ లెట్ ఇట్ స్టార్ట్ రైట్ టైం మనం స్టార్ట్ చేయాలి. Yeah, good morning all. This is Dr. Kumaraswamy. I request Harika ma'am to introduce Dr. Asadi Srinivas sir. He is a well-renowned professor and he is giving lectures at various universities, reputed universities. So we are very fortunate to have you in this session, sir. I request Harika ma'am to introduce Dr. Srinivas.
Very good morning, sir. Very good morning, all of you. Today I am going to introduce Dr. Asadi Srinivasulu garu, who received his BTech CRC from Sri Venkateshwara University, Tirupati, and in the year 2000 and completed MTech in Intelligent Systems from IIIT, Allahabad. And next he has received his PhD from JNTU, Anantapur, under the supervision of Dr. CHDV Subbarao. Currently he is working as a head research and professor of Information Technology at Blue Crest University, Monrovia, Liberia, and he has 19 years of teaching experience and industrial experience. He served as a head Department of Information Technology in SV College of Engineering, Tirupati, and to his credits, he is having RAD, RFT, DB2, RTC, TDS certifications, and also 9 NPTEL certifications and 4 spoken tutorial project certifications from IIT Bombay, and also 2 solo learn certifications on CPP. And his areas of interest are data science, big data analytics, data mining, artificial intelligence and robotic process automation, cloud computing, pattern recognition, machine learning and software engineering. He is a professional member of IEEE, and also he is an editorial board member in iManager's Journal on Cloud Computing, Seria Journal of Computers, and International Journal of Advanced Research in Computer Science and Electronics. And he has published more than 195 papers, 12 SCI, 15 Scopus and WIS, and remaining are UJC listed, international journals and conferences. He attended more than 185 workshops, symposiums and seminars. And he has conducted and acted as a resource person for more than 115 international and national conferences. And he visited many countries like Malaysia, Thailand, Singapore and Liberia. And thank you, sir. Thank you that you are here and you are going to share your immense knowledge to our students today. And we are very happy and enthusiastic to have the session today, sir.
Yeah, thank you, madam, for nice introduction. Warm welcome to one-day short-term course on artificial intelligence applications using machine learning and deep learning techniques with various case studies. So, intelligent behavior in a machine, that is example robot. I am going to demonstrate various case studies and applications by using machine learning and deep learning techniques. Okay, so before going to this short-term course, I would like to introduce what is happening in this world. Within 1 minute,
Yes, sir.
how many users are connected to this internet world, digital era? See, so many users, if you see the statistics of this slide, 2.1 million snaps created, 694,444 hours watched in Netflix, 3.8 million such queries, 1 million login within 1 second, not in a day, not in a quarter, not in a half year or year. It is just 60 seconds. If you see the statistics, you will feel amazing. 4.5 million videos viewed within 60 seconds. And 41.6 million messages sent within 60 seconds. See, this is about 1.8 million emails sent within 60 seconds. Sir, where the data is going? How the data is coming? Where is the resource? How the data is flowing? How many servers are required? These many questions you may get a doubt. That's why in the backend we are using cloud computing concept. Cloud computing is nothing but internet-based technology, pay and use. Without internet, there is no service, any kind of service application. So the backbone of cloud computing is data center and the virtualization. Data center is nothing but collection of high integrated servers at one place is called data center. If you see Google data center, Microsoft data center, Facebook data centers, they have constructed beside seashore. And one more backbone of cloud computing is virtualization. Virtualization is the ability to perform multiple tasks in a single system is called virtualization. In order to create virtual machines, we are using various virtualization technologies such as VMware technology, hypervisor, Zen, virtual iron. These are the four popular virtualization technologies we are using in order to create virtual machines. So this is a small background of cloud computing. If you see now, www.internetlivestats.com. If you have internet, please click this URL. You come to know the real-time statistics. What is happening in this world and how many users are connected to in this world. See now, my screen is visible, sir. Kumar sir.
Okay, sir.
Hello, madam. My screen is visible.
Yes, sir, it's visible.
Yeah, thank you, madam. Please see, check here www.internetlivestats.com. If you see how many internet users are connected now. See here the number. Can you read this number? Very huge number. See here, and the total number of websites open, total number of websites. Email, see, number is changing drastically here. Google searches today, blog posts written today, tweets sent today. So, how many users are connected? Now see, within 1 second, in this second, how many videos viewed today on YouTube? See, this number you cannot read, very fast changing. Photos uploaded today, and Facebook active users, and Google active users. See, so many users are connected to this internet world. So Pinterest active users, Skype calls, see, Skype calls and websites hacked today. These are the statistics. And tablets sold today. How many tablets sold today? And smartphones sold today. So computers sold today. And what about the internet traffic today? Can you read this number? See how much GB internet traffic today, electricity used today, and carbon dioxide emission today. So these many statistics about internet live statistics. So this is a small practical about in this digital world. We are living in this digital era. How many users are connected? So how the data is storing, how the data is representing. So that is about statistics, internet live stats.com. So that is practical information about www.internetlivestats.com. So today I am going to explain the practical demonstration of artificial intelligence applications. So wherever I am going to give a presentation on webinar, these are the topics I am going to explain, like data science applications and as well as AI applications, machine learning applications, deep learning applications, and statistics applications. By using Python only, I am going to demonstrate all the applications. This is my syllabus. Wherever I am giving presentation, these are the subjects, my research area. I have completed my Master of Technology with specialization intelligence systems. That means artificial intelligence systems. So there I have pursued a deep knowledge on artificial intelligence, data mining, artificial neural networks, and machine learning, statistics. So recently, last 2 years onwards, I am concentrating on Python programming. Because why I have chosen Python programming, it is so popular for a number of packages are available. Whatever the irrespective of subject, you can have a various number of packages. That is the beauty of this Python programming. Today I am going to demonstrate various applications like COVID-19 virus prediction and detection application, Omicron virus prediction and detection using machine learning and deep learning techniques, and Ebola virus prediction and detection applications, prostate cancer, breast cancer, lung cancer, and as well as traffic data analytics, various case studies. Today, heart disease data set I have taken into the account, and I have applied AI techniques, and even electrical data set I have taken, various traffic data analytics, time series data applications, market basket analysis applications I am going to demonstrate. So before going to the concepts of artificial intelligence, I would like to give a small glimpse on how we are measuring the data in artificial intelligence. So a computer understands only ones and zeros, binary language. If you press capital A in the system can it read as it is capital A? So internally it will convert. Yeah, very good, madam. So internally it will convert into ASCII format. ASCII stands for American Standard Code for Information Interchange. Capital A value is 65. If you divide it by 2, the number is 10001. Like that, you are getting a binary equivalent of 65. Within fraction of seconds, the number is converting, and it is interpreting the data, and immediately we are getting the output. That means whatever high-level languages we are using like Java, Python, Smalltalk 80, and JavaScript, Go language, everything, these are the high-level and object-oriented programming languages. So internally it is converting into ASCII format. So measuring the data in artificial intelligence, these are the terminology, you must know it. Being a computer related or electronic related or any kind of irrespective of department, each faculty and each student must know the terminology. 1 bit is equal to 0 or 1, 4 bits is equal to 1 nibble, 8 bits is equal to 1 byte, 4 bytes is equal to 1 word, 4 words is equal to 1024 bytes, 1024 bytes is equal to 1 kilobyte, after kilobyte, megabyte, gigabyte, terabyte, petabyte, hexabyte, octabyte, zettabyte, and yottabyte. Hi, I am Robo. My speed is 1 zettabyte and my memory is 1 yottabyte, 1 terabyte. Like this dialogue, after watching that Robo movie only, we came to know, oh, this much terminology is presented. Yesterday night, again I searched in the Google, there are 2 more terminologies presented. That is, 1024 yottabyte is equal to 1 brontobyte, 1024 brontobyte is equal to 1 geobyte. If you ask me after geobyte, there is no terminology. That is called infinity. If you take the data sizes in normal range and big data range, 10 power 3 is kilobyte, 10 power 6 is megabyte, 10 power 9 is gigabyte, 10 power 12 is terabytes. Same if you see in big data range, 10 power 15 is petabyte, 10 power 18 is hexabyte, 10 power 21 is a zettabyte, and 10 power 24 is a yottabyte. 10 power 27 is a brontobyte, 10 power 30 is a geobyte. Not a geo. This is a geobyte, GEOBYTE. So this is the way we are measuring a huge volume of data in server or data center or in computer terminology. So today I am going to explain artificial intelligence half an hour theory part and half an hour practical demonstration I am going to share with you. So, introduction to artificial intelligence and what are the fundamentals of artificial intelligence, and I'm going to explain expert system and AI tools, A-star algorithm, why we are using, and what is meant by fuzzy logic and soft computing. And if you are taking any kind of database related applications like data manipulation, we need to do what is the cleansing, munging using data analysis, visualization using Python, statistical technique, data preparation, feature selection, and artificial neural networks, TensorFlow. It is a framework. And a single layer perceptron, multi-layer perceptron, various classification techniques like linear regression, non-linear regression, logistic regression, and finally I am going to demonstrate convolutional neural networks. So this is my small agenda. And what is the prerequisite of artificial intelligence? In order to develop any database applications or data related applications, so data is nothing but a raw material, maybe a fact or image, audio, video, text, graphics, animation, etc. And so prerequisite after pre-processing the data is called information. So information, you may not find any kind of inconsistent data, noisy data, dirty data, irrelevant data. Such type of data is called information. Then collection of interrelated data is called a database. And in order to manage, something is, 1 second, madam. There is a animation, I'll remove it.
Any issue, sir?
Just a minute, madam.
Anime slide.
Madam, my screen is visible?
Yes, sir. Yes, sir. Visible.
So, in order to manage the database, we are using various kinds of softwares like relational databases, non-relational databases. If you are using SQL, MySQL, Teradata, MS Access and DB2, those are the relational database tools. So there is a schema, there is a label, there is a procedure, there is a relation. Such kind of databases are called relational databases. And there is no schema, there is no relation, there is no procedure, but we are creating a database with the help of non-relational databases such as Mongo database, Hive. Combination of data plus DBMS is called database system, and storing of small amount of data is called a data mart, that is called a subset of a data warehousing. Collection of data marts or online analytical processing is called data warehousing, and extracting meaningful interested patterns from the huge volume of data is called data mining by applying classification, clustering, association, rule mining, outlier detection, recommender engine, etc. Then we are dealing with the big data sets like volume, velocity, variety. Volume says that size of the data, and variety says that various kinds of files we are handling in the real-time environment, and velocity says that the speed at motion, the way we are downloading files and uploading files, that is whether we are handling real-time data, near-time data, or structured data, unstructured data. The speed, we can call it as a velocity. Then final AI application, intelligent behavior in a machine, is called artificial intelligence. And science and engineering, in order to develop various applications and extracting insights by applying the various machine learning and deep learning algorithms. This is a prerequisition chart of artificial intelligence. So the beautiful definition of artificial intelligence, the science and engineering to make intelligent applications, intelligent behavior in a called artificial intelligence. Intelligence is nothing but the ability to learn or understand, to deal with new or trying situations, specifically like the ability to reason, the ability to solve problems, the ability to act rationally and efficiently, the ability to act like a humans. That is called artificial intelligence. If you see in artificial intelligence in broader way, so sir, some disturbance is coming. Hello, madam. Unmute them, madam.
Yes, okay, sir.
Yes, sir. Yes, sir. Some disturbance is coming.
We'll see. Please, all of you, be mute on yourselves. Please mute yourselves.
So artificial intelligence is a popular branch of in computer science that concerns with building intelligent
No audio, sir.
All muted. All are muted at once.
అంటే తను కూడా మ్యూట్ అవుతాడు.
అదే మ్యూట్ అయ్యారు.
మ్యూట్ చేయి. మ్యూట్ చేసి వాళ్ళని మ్యూట్ చేస్తుంది.
అది క్లిక్ చేసిన ఆప్షన్.
Ask participants to mute themselves.
Please mute yourselves. Unmute అవ్వట్లేదు.
స్పీకర్ అవుతుంది.
Yeah. Done. Sir, you may please.
Hello, madam. My voice is audible, madam.
Yes, sir. Yes, sir. Sorry for the inconvenience.
Yes, madam.
You can continue.
So, yeah, in artificial intelligence, we have two more subjects like machine learning is a branch of artificial intelligence, and deep learning. Learning from the observational data is called deep learning with deep manner. So various input and hidden layers we are incorporating while implementing any sort of complex database applications. Learning from the observational data, self-adaptive algorithms that can be learned from data without using a complex set of rules. That is called machine learning. There are three kinds of learning approaches we are using: supervised learning, unsupervised learning, and reinforcement learning. And based on the label, we are classifying the data. That is called supervised learning. There is no label, there is no target class, but I don't know how many classes it is going to classify. Such kind of learning is called unsupervised learning. Based on the similarity measure, we are calculating based on the Euclidean distance, square root of x1 minus x2 whole square plus y1 minus y2 whole square. That is called Euclidean distance. And then reinforcement learning, learning from the mistakes, learning from the any errors. That based on the punishment and reward, we are solving the various gaming applications that comes under reinforcement learning. So these subjects comes under artificial intelligence. So all the participants and the students may get doubts, sir, where this AI is used and where to I start, whether I have to start machine learning, deep learning, or mathematics or statistics. So in that question, I am going to clarify. So this artificial intelligence is used in predictive analysis, real-time operations management, customer services, human resource related applications, even supply chain management applications, risk management and analytics applications, pricing and promotions applications, and customer insights and applications, research and development applications. Various applications are available under artificial intelligence. So there are two types of artificial intelligence. Usually we can, based on the ability we are classifying, and based on the functionality we are classifying. If you see based in only one area has no memory, and if you see narrow AI, we are using machine learning, and in general AI we are using machine intelligence, whereas in based on functionality, theory of mind we are using to understand the thoughts and emotions of other intelligence entities like face recognition applications, speech recognition applications, etc. Then super AI, we are using mission consciousness, and based on functionality, we are applying self-awareness concepts like has human-like intelligence, is sentient and conscious related functionalities we are performing. There are 5 most important concepts of artificial intelligence. So machine learning is a important concept in artificial intelligence. Learning from the observational data is called machine learning by applying various supervised, unsupervised, and reinforcement learning algorithms. Then comes to the deep learning, learning from the observational data with a deep manner by applying various input and hidden layers are unlimited. Then comes to the neural network, study of artificial neural networks in order to solve complex and health-related applications. Then collaborative filtering is nothing but by applying filtering, we are classifying the data. If you take a Gmail application, Gmail is a communication application. There we are classifying data, spam-related data. We are moving to the vault or any kind of. We are applying filter like a spam folder. That is the best example for a collaborative filtering. It is a classification technique. And predictive intelligence, we are predicting the weather forecasting based on past temperatures. Like 1 month data I am observing, last day and yesterday date, and tomorrow's date I am predicting by applying various prediction algorithms. Then 3 types of artificial intelligence, like artificial narrow intelligence, artificial general intelligence, artificial super intelligence. Okay, in stage 1 we are solving machine learning applications, specializes in one area and solves one problem. And examples like Siri, Alexa, Cortana, these are the chatbots, various intelligent robots. These days we are using humanoid robots like Asimo, Chinko, Chihira, Sophia. Sophia recently took the citizenship of Saudi Arabia. Then comes to the artificial general intelligence, stage 2, mission intelligence. It refers to a computer that is as smart as a human across the board. Like we are solving various speech and biometric applications in this category. Then third, stage 3 comes under artificial super intelligence. So mission consciousness, here we are integrating with various artificial neural networks, deep learning techniques, data mining techniques, statistical techniques, everything. And intellect that is much smarter than the best human brains in practically every field, like in Internet of Things related applications with the help of artificial intelligence tools and techniques. We are developing in this stage 3. Then artificial intelligence major components and major subjects like expert system. Expert system is nothing but we are building if-then rules, and we are developing rules and regulations and making a database is called expert system. And then neural network, study of artificial neural networks. Then robotics, intelligent behavior in a machine is called robot. There are various kinds of humanoid robots are presented. And fuzzy logic is nothing but it is a major concept in artificial intelligence. And fuzzy logic gives us the degree of freedom. If I am asking the value between 0 to 1, few faculty are saying 0.4, few faculty are saying 0.7, 0.9, 0.5. Which value I have to take into the account? So that is a degree of freedom. So that is called fuzzy logic. Then natural language processing, study of different languages or linguistics. I would like to convert a speech recognition application and converting one language to another language. Comes to by using the NLKT, Natural Language Toolkit. It is an artificial intelligence tool is there. With the help of that one, we can do various applications. Then, if you see what are the branches of artificial intelligence by applications. Today, our main aim of this short-term course, we need to study what are the various applications are presented in artificial intelligence. If you see this diagram, you come to know how many application domains and application areas are presented. See in left side, if you see the left side, knowledge management concept mining. So under this one, we are discussing various concepts like data mining, text mining, process mining, and email spam filtering, and information extraction. We are using activity recognition, image retrieval, and named entity extraction. This comes under knowledge management concept mining. Then machine learning. Under machine learning, first of all, you must know what is machine learning, what kind of learning approaches we are using. So under machine learning from the observational data is called machine learning, and with the help of supervised learning, unsupervised learning, and reinforcement learning, we are solving various machine learning related applications. And constraint, conditional models, deep learning, natural modeling fields, we are using under machine learning. Then comes to the natural language processing related applications like chatbots, language identification, natural language user interface, natural language understanding, and mission translation, statistical semantics, and question answering, and semantic translation. These are all applications comes under natural language processing. Then nonlinear control related applications, then pattern recognition applications like optical, character recognition, handwriting recognition, speech recognition, face recognition. These are the applications under pattern recognition we are solving. And under robotics, we are solving behavior-based robotics, cognitive-related robotics, cybernetics-related applications, and development robotics, and epigenetic robotics, and evolutionary robotics. These knowledge comes under these applications comes under robotics. Then speech generating device related applications, strategic planning, vehicle infrastructure integration, virtual intelligence, and virtual reality. These are the complete application domain areas. If you see the right side, artificial creativity, artificial life, automated planning and scheduling, automated reasoning related application, automation application, especially mechanical engineering automation related applications, automatic target recognition applications, and biological inspired computing applications. If we take computer audition applications like speech recognition, speaker recognition, then computer vision related applications like image processing, intelligent word recognition application, object recognition, then object mark recognition. So there you can see the handwriting recognition, optical character recognition, automatic number plate recognition. That is in traffic data analytics we are using. Facial recognition system and silent speech interface. Various applications we can see in under computer vision related applications. Diagnosis like health data analytics related applications. Then expert system like we are building if-then rules and making a very good expert system based on the conditions, and we are collecting various constraints of the application. We are developing expert system, then we are solving various AI applications. So in expert system, we can see the decision support system, that is called DSS, then clinical decision support system, then game artificial intelligence, especially game related applications like reinforcement learning approach we are concentrating. Reinforcement learning approach is nothing but learning from the mistakes and learning from the errors, and we are solving various gaming related applications. Here we are using deep NQ. Some algorithms are famous under reinforcement learning. Then see in game artificial intelligence, computer game bot and video games AI applications, computer chess, computer Go, general game playing, and general video game playing, game theory. All the applications comes under game artificial intelligence. Then a hybrid intelligence system combining various biometric applications with Internet of Things related applications. Internet of Things is nothing but collected all the real-time objects in a network is called Internet of Things. Nowadays we are using more sensors. If you take your mobile, there are 5 to 10 sensors are presented in this mobile. That means we are sensing the data and storing in the system and processing and computing, and finally we are generating our own interested applications. Then intelligent agent architecture, cognitive architecture, intelligent control related applications, and knowledge management related applications, knowledge representation, semantic web. This is a complete mind map of artificial intelligence applications. Okay. And if you see in artificial intelligence in action, these are the various tools and techniques we are applying for various applications. Major concepts like machine learning. There we are seeing deep learning, supervised learning, unsupervised learning, reinforcement learning approaches under machine learning. And natural language processing, study of different languages or study of linguistics is called natural language processing. And here we are solving natural language understanding problem, natural language generation problem, and dialogue system related applications. Then expert system, computer vision like machine vision processing. We are solving various speech and image recognition applications like acquiring the processing, acquiring the video, acquiring the data, processing the data, analyzing the data, and classifying the data. Planning and optimization, robotics. And if you see what are the various features of artificial intelligence, so these are the major features. Learning from the observational data with a deep manner is called deep learning. Here we are using various classification techniques like DNN, deep neural networks, CNN, convolutional neural networks, and RNN, recurrent neural networks, etc. Face recognition application comes under biometric applications. We are extracting various features on the face, like moles on the face, distance, forehead distance, distance between mouth and the nose, various. If you are increasing number of constraints, definitely recognition accuracy is 95, 98, etc. Then automate task. Nowadays, with help of mechanical engineering, we are solving and we are developing various automated related applications. Data ingestion, we are extracting and we are developing various database related applications. Then cloud computing. Cloud computing is nothing but internet based technology. Without internet, there is no service, any kind of service applications. The major limitation of cloud computing is internet. So pay and use. There are three types of services: software as a service, platform as a service, and the infrastructure as a service. And three types of clouds are majorly classified, like public cloud, private cloud, and hybrid cloud. Then comes to the quantum computing. 10 power 9 is called nano, 10 power 6 micro, 10 power 3 kilo. Like we are solving various small we are extracting very minute feature of any substance of a particle, and we are solving various applications. Then finally, chatbots. Chatbot is an intelligent application like Alexa. Okay, it is solving only one kind of application. If you open any website, in the right side immediately one dialog box will occur. How can I help you? This is a chatbot application. Then comes to the one picture with artificial intelligence. Artificial intelligence and machine learning, deep learning, various kinds of subjects I have integrated in a single image. That is, if you see in the in a green line, that portion I am going to explain now. Artificial intelligence. See, we are developing a model with help of algorithms or tools and techniques by applying various neural networks models, data production related applications, and intelligent agents related applications, and even deep learning concepts we are integrating in order to solve complex related applications. This comes under the artificial intelligence. Then if you see the artificial intelligence components, especially what are the development tools are presented under artificial intelligence. So CUDNN, deep neural networks, Jupyter, it is a PyCharm, it is an editor of Python programming and R programming in order to solve. And if you see the languages, what are the languages we are incorporating in order to solve real-time applications of artificial intelligence? So Julia, and as well as Python, R, Java, JavaScript, and Go. Recently, Google company developed Go language. It is a function and object-oriented programming language. Then comes to the data platforms like Spark, Hadoop. These are the big data technologies platforms in order to processing and computing. Then PostgreSQL, SQL Server, Hadoop. These are the data platforms. And AI tools like H2O.ai and XGBoost, TensorFlow. These are the various frameworks we are using in Python related artificial intelligence application, exploration and visualization. See, after the completion of your application, principal or director or manager would like to see the results through visualization, through bar chart, pie chart, line chart, scoreboard, dashboard, with the help of Excel or various tools we are using in order to visualize R programming, MATLAB, and Python. In Python, Matplotlib we are using, and various visualization tools are available. Data ingestion tools like SQL Server and Python, PyTorch. These are the various AI tools. Then what is the difference between machine learning versus artificial intelligence. If you see, the AI is a human intelligence demonstrated by machines to perform simple to complex tasks. Whereas in machine learning, it provides machines that ability to learn and understand without being explicitly programmed. That is comes under machine learning. The idea behind AI is to program machines in more human ways or smart ways, whereas in machine learning, the key to technique computers to think and understand like we do is machine learning. So it is based on characteristics of human intelligence. In machine learning, it is based on the system of probability. It is used in healthcare applications, finance-related applications, transportation applications, aviation, marketing, media application, education, etc. Whereas machine learning, it is used for optical character recognition, web security, imitation learning, or any health-related applications also we are using machine learning techniques. What are the advantages and disadvantages, that is called pros and cons of artificial intelligence? So increased efficiency, that is advantage, reducing human risk, aid in decision making, availability. And whereas the disadvantages like cause of unemployment, after 10 years my job may not be available because of robots are entering into the real world field. Then a high initiative investment, dependency on machines, lack of creativity. These are the drawbacks of artificial intelligence. Now I am going to demonstrate all the practical applications by using top 10 most popular artificial intelligence models. I think last 4 to 5 days you might have seen various kinds of Internet of Things related applications and cloud-based applications, machine learning, artificial intelligence, and deep learning applications by using these top 10 models like linear regression, logistic regression, linear discriminant analysis, decision trees, naive-based classification, k-nearest neighbor application, learning vector quantization, support vector machines, bagging and boosting random forest algorithms, deep neural networks. These are the top 10 algorithms recently I have applied in my data science research laboratory in order to solve various applications. Last 2 months back, I have joined as a data science consultant at Deloitte, Delhi. So I'm working on machine learning applications and deep learning applications, various artificial intelligence tools and techniques. See, what is the difference between data scientist versus artificial intelligence? See here factors like scope, types of data, tools and applications. So in data science, it involves various underlying data operations, whereas in artificial intelligence, limited to the implementation of machine learning algorithms based on that subject scope. Then types of data, structured and unstructured data. Which data is called structured data? With help of relational database tools like SQL, MySQL, Teradata, we are creating tables. Collection of tables is called database. To manage the database, we are using various relational softwares. Unstructured data is nothing but there is no schema, there is no relation, there is no syntax. But we are creating a database is called unstructured data with the help of Mongo non-relational databases like Mongo database, Hive, HBase, Scoop, etc. So in artificial intelligence, it's standardized in the form of embeddings and vectors. Tools in artificial intelligence, what are the tools we are using? Scikit-learn, Caffe, PyTorch, TensorFlow, Shogun, Mahout. PyTorch, TensorFlow, sklearn, these are the frameworks regularly. Every day I am using in Python programming in order to solve artificial intelligence and machine learning and deep learning related applications. And applications like in artificial intelligence, manufacturing like manufacturing related applications, automation related applications, robotics, transportation applications, and healthcare related applications. So what companies think about artificial intelligence? Just look like, see here. First, why industries are preferring nowadays artificial intelligence? How Indian government and AICT and UGC, they have introduced a specialization in BTech curriculum, BTech in artificial intelligence. How these industries are think like this. See here, broadly I am going to explain. So data related, like where the how you are selecting the data, where the sourcing of the data, and synthetic data, that is comes under you can call it as a constraints. Then what is actually in data science or artificial intelligence? We are solving data engineering and modeling applications. Finally, value. We are getting operational, nothing but recognition related applications, deployment related applications, and monitoring and retraining. So this is in-depth knowledge of why these companies think AI look like data and data related applications, and then finally we are getting the value. Then if you see the top 10 interesting stats about artificial intelligence, by 2021, 80% of emerging technologies will have AI foundation nowadays. Then title 2, if you see, AI can increase business productivity by 40%. They already started, and already we are using this artificial smart applications with help of Internet of Things. Then 63% of people prefer to message a chat box. Already we are using chat bot like Alexa, and humanoid robots like Sophia, Chinko, Chihira, with a human when communicating with a business, various applications we are solving. Then title 3, title 4, according to the different studies, there are more male employees in AI related jobs than female. At least 71% are men are learning artificial intelligence. These are the statistics. And title 3, if you see, by 2025, AI is expected to become a $60 billion industry. You can expect more grass by 2025, $60 billion industry wise. Then title 6, if you see, the experts predict that by 2020 or 2022, 85% of all customer service interactions will be handled without the need for a human agent. Yes, nowadays we are booking even Amazon, Flipkart, retail marketing, e-commerce related applications. Automatically, if you search in mobile, for one mobile, tomorrow it is going to show you, recommend, would you like to purchase this smartphone? How it is coming? Based on your behavior, based on your interest, they are in the background, they are applying various prediction algorithms, behavior algorithms, sentimental algorithms. Okay, so these are the various statistics about artificial intelligence. Then this is the impact of artificial intelligence on jobs. So replacing redundant jobs in near future after 5 years, after 10 years, and various problems for human being. We have created robots, so finally we may not get jobs in industry or any manufacturing companies especially. And see, if you see the robots statistics, already chatbots enter into the industry related mail carrier, Gmail carrier, or any kind of related automated task. 68% now robots are performing, and jewelry related 68% of robots are performing. Logging worker, I mean entering into the entering into the building and outgoing of the building. So like login statistics. So you can call it as a logging worker. 79% robots already entered into the market. Farm laborer like 97%. Drill press operator 94%. Insurance underwriter 99%. Already these robots are entered into the industry. Job profiles in AI like robotics, like become scientist, big data engineer, business intelligence developer, data scientist, machine learning engineer, product manager, AI research scientist. And now I'm going to demonstrate practicals. So this is a heart disease related database application. So now I'm going to demonstrate. I have used Python programming, and I'm sharing this PPT to your coordinator, sir. You can also execute this kind of applications. So this is the data set I have taken for a support vector machine, heart disease input data set I have taken, and age and gender and various symptoms of a heart patient. And this is the program support vector machine. I have imported pandas. Pandas is a framework, and it handles data set related. What is the size of the data? How many columns are there? And what is the major size of? What is the major attribute of the data set? What is the topmost element? What is the minimum element? Maximum value, minimum value, standard deviation. Every operation comes under the pandas library. Then from sklearn, scikit-learn is one of the framework under Python. I have directly using a support vector machine algorithm under this sklearn. From sklearn.svm, I'm importing as svc. Then from sklearn, import metrics. What are the metrics I'm considering? From sklearn.metrics, import classification, report, and confusion matrix in order to check the accuracy level. Then columns, variants like skewness, kurtosis. This is the column names. The column names I have taken A, sex, CP, and trust BPS, cholesterol, FBS. These all are various. This
Sir,
is the CSV file I have taken.
Excuse me.
I'm going to demonstrate. Hello, sir.
Sir,
Madam?
Actually we have session up to 12:15
madam.
only. Please try to wind up because we have another subject expert also. The slot from 12:15 to 1:15.
Oh, sorry.
No issue, sir. Actually, the session is
madam.
very interesting, but we are in lack of time, sir.
Yeah, it's okay, madam. Now I'm going to demonstrate. How much time is there, madam? Sorry, madam, I don't know. Otherwise,
within 5 minutes, can
I
you
could have
wind up,
executed.
sir? Within 5 minutes.
Yes, madam. Yes, madam.
Thank you, sir. And sir, please do share the PPT content to us so that it will be useful for the faculty
Yes,
as well
madam.
as participants.
Yes, madam. I'm going. So this is the way we can execute a Python svm.py. So I'm executing support vector machine like various applications I have incorporated in this PPT, and you can execute. See, this is one of the SVM classifier, and this is the way I'm generating graphs for this application. And one more application I'm going to show you, Python. This is a heart related heart data set application. So it is going to show you the accuracy, precision, recall. This is the way we are executing a support vector machine to and one more application, Python artificial neural networks. So artificial neural network I have applied on heart data set, and as well as the data set related to CSV file format. So now I have incorporated in this technique TensorFlow. Now the program is executing. See here, all of you. Please observe. My screen is visible, madam.
Yes, sir. Yes, sir. It's visible.
Hello, madam.
Visible, sir.
My screen is visible.
Yes, sir.
Yeah, this is artificial neural network, sir. See, I got accuracy 93.16, and a few more applications like logistic regression or linear regression. See here, to predict the future values, I'm generating a graph, and as well as the values related. So this is the linear regression application. Like we nearly 20-25 algorithms I have executed. So there is no time. Sorry, I thought that time is there. I'm going to demonstrate.
Yes, sir.
One more
we are also
application.
feeling the same, but actually we have 3 sessions today, and today is the closing.
Oh, sorry. Okay, madam. So this is the logistic regression, and one more application I'm going to show you. Madam, otherwise you do one thing, madam. I am going to share with you my complete presentation, so that they will execute various health related applications, and transport related applications. Various applications are there.
Okay, sir.
Yes, madam.
Please do share with our coordinator, sir. Coordinator Dr. V. Kumaraswamy, to his mail ID. Please do share all the content to him. And,
please, madam, you ask participants any doubts related my session, madam. Please let them ask, madam.
Okay, sir.
Yeah, please.
Any doubts?
How many participants are there, madam, today?
Today, actually, offline session more than 60 to 70 are there, sir. Online 33 have logged in, sir.
Okay.
We have more than 100 participants.
Okay, yes, madam. Please let them ask any doubts.
Hello, sir.
Yeah. Please introduce. You just give your name and so that ask your query.
Thank you so much for sparing your valuable time. I know that you were traveling earlier yesterday. Because of that, we shifted the schedule from yesterday to today.
Yes,
participants can understand the problem. So, but we had a very good interactive session, sir. Thank you so much. We will make use of your services in future as well.
Yes, sure, sir. Any doubts from the participants? Please ask me. I'm going to clarify your doubts. If anybody would like to execute in Python, sir, please share my mobile number and email ID so that they can interact with me. Personal training also I'm going to train on Python programming by solving various artificial intelligence applications or machine learning or any deep learning applications. Hello, my dear participants. Any doubts?
Okay, sir. We will definitely share. Thank you so much, sir. Next expert is waiting. So we'll continue with the program.
Yeah. Sure,
okay.
Sir, please share my YouTube link to my participants, sir, so that they will subscribe and have. Yeah, thank you.
Definitely, sir. Definitely.
Thank you, sir, for giving me this wonderful opportunity.
Thanks a lot.
Very good afternoon, all of you. I think so. Dr. D.V. Murli Krishna, Director Tech Vedika is present here.
Yeah, hi.
Hello, sir.
Yeah,
Hello, sir.
Murli, I'm here. Yeah.
Sorry for the slight delay in the session because the previous subject expert was having a lot to present, but due to some time constraints, we had stopped his session. And I'll introduce you, sir, and later we can go on with the session.
Okay.
Good afternoon,
Yeah,
everybody.
that's no problem. Yep, go ahead.
Murli Krishna is a director of technology at Tech Vedika and having a overall experience of 30 years as a technical architect in the software industry. His specializations are in microservices, cloud, AI and ML, and product development. And during his career, he worked with Tier 1 companies in India, Malaysia, Singapore, and USA. He did his BTech in CS from AU College of Engineering, Voltaire, and MBA from Haas School of Business, California. Thank you, sir. And today, sir is going to take a session on AI-enabled IoT in warehouse and retail analytics. You may carry on with the session, sir.
Okay. Yeah, thank you so much for the intro, ma'am. So I'll just share my screen and I'll take it from there.
Yes.
Okay. Good afternoon, everyone. Yeah. Like in the intro, my name is Murli, and I also have with me Bhaskar Paila. He is a colleague of mine. He is the head of our AI division. And first off, I want to thank Dr. Kumaraswamy for giving us an opportunity to present all the cool stuff that we do in our company. And we do most of them, whatever we present, but we are more or less focusing on two things, like in the title. One is what we do with AI and IoT in warehouses. That will cover as the first part, and then we'll move on to the second one, which is also more interesting. It is how we do it in retail stores for analytics. All right. So I just put together a brief agenda. First I'll do a quick intro, and then we'll move on to warehouse optimization using AI-enabled IoT, and then we'll cover IoT and AI in retail, and then we'll do a very brief Q&A. So that's the agenda, and I request you to come up with some questions, and we can address them towards the end. Very quick intro of our company. We are from Tech Vedika. We are from Hyderabad. Company is founded in 2010, so we are kind of 12-year-old, and we have certifications, and we are also certified AWS partner, and Intel has one AI Builders program, so we are also partners with Intel on their AI Builder program. So we have around 150 over employees, and around 50 of them are specialized in AI and ML, deep learning, and all these techniques. So over these so many years, we have lots of customers from all over the world, US and Europe. And we also have AWS managed services, and we also do product engineering for customers around the world. So we have around the clock services. So like I said earlier, we'll focus only on the vision-based AI and ML that we use for the IoT part for two of our products that are out there. Like one is WareTrack that we use in warehouses, and the other one is Item Track that we use in retail. All right, let's start off with the warehouse part. So most of us are familiar with what warehouses are like. There is these what we call pallets, these big boxes that are moved from one place to another, and they use forklifts to do that. So how do we use AI and IoT and computer vision to make things better for handling stuff in a warehouse? So that's the focus of the. Okay. So when you go to warehouse logistics, right? So there's lots of issues right now with the traditional systems. There are
warehouse management systems are there, and there are handheld devices that they use. So there is quite an amount of automation that is in place, but these are not really standard, and there are different WMSs, and there are lots of human errors that occur. So there is lots of inventory mismatch. There are things out of sync. I'm sorry, maybe my screen is not visible to you folks.
Yes, sir.
So Bhaskar alerted.
Yes, sir, you have not shared the content actually.
Correct. Yeah. So now do you see? Now is it shared right now?
No, sir.
No, not yet. Okay, I'll stop sharing and share again. So does it show now? Sorry about.
Yes, sir.
No? Okay. All right. Yeah. So we didn't miss much. Right? I just covered this part about our company, and then yeah, this screen is about the warehouse, how it looks, and all the pallets and forklifts and stuff. So this is the one that is of more content here. Like this is what we need to do for making things better in a warehouse. Right? We want to provide vision analytics using cameras and sensors. So we want to automate lots of human activities, right? Today they are being done using handhelds and stuff, but we want to automate. And we also want to provide real-time visibility into their operations and all the spaces that we need to track, all the pallets, carts, everything. If you have proper visibility, you cut down on errors and exceptions. So we have 4 different kinds of things that we use to get this to work properly. So number 1 is the machine learning. That's our interest for today's discussion. So we do object detection. We detect the pallets, the forklifts, the persons, and those guys, and we track from where these things are going from one zone to another zone, and we'll see, and then we'll update the WMS accordingly. Likewise, we can do route optimization, like if it needs to go from one zone to another, what is the best way to go, and if there is any blockages in between. So the vision analytics will give help in that regard. So for this, we use deep learning techniques, and we also use OCRs for recognizing some of the codes and the text that is available on the boxes. The next one is computer vision, where we use analytics for all the optimization of tasks. So we have put away tasks, we have pick up tasks. So we need to optimize based on how to pick up stuff. If we are using a FIFO algorithm, all the things that are going to expire pretty soon should be picked up first. So those kinds of things we use. And we also use guided navigation, like I mentioned earlier. We use these IoT sensors for tracking of forklifts. That's for the real-time tracking, where they are in terms of the warehouse, which location. And we also use some kind of waste.
Excuse me, sir.
Yep.
Sir, the voice is not so audible, sir. It's not clear.
Sorry about that. Yeah, I'll get closer to the microphone. I hope it is better now.
Yeah, now it's much better now.
Okay. So
thank you, sir.
Yeah, thanks for alerting me. So this is about the IoT part, where the sensors are there for real-time tracking of forklifts and weight. Like if there is a pallet that is lifted by a forklift, we'll get to know using the weight sensors. So these are the key elements. And we also have enterprise integration, where when we roll out our system, it has to work alongside the current WMS or ERP or CRM, all these systems, whatever are there in the enterprise. We have to work alongside them. So we have event-based integration. So these are the key components in our warehouse optimization product. So I think we covered a little bit, but here we'll get into more detail. So the blue parts are the challenges and how we use automation to overcome those. So planned storage of goods in high inflow environment. There will be thousands of pallets that are coming in and going out. So there's no perfect planning with whatever current systems they have. There will be things that are out of sync, and the inventories will be placed in different places than planned, and things like that. So if we use this AI and enable the cameras, then we'll cut down on all these errors that occur. So we'll provide a dynamic product storage. So we'll control the put away and pick up. And then there is high unloading and loading times. That's another challenge. So once we automate the item verification using our cameras, so you don't have any manual intervention there. You don't need to use any handheld devices. Things are automated. Things move very fast. So unloading and loading staging areas, if they are located closer to docks, with our AI-assisted pallet tracking and put away location capture, we'll do things very efficiently. The truck can leave very soon after the things are unloaded. So the reconciliation will be very fast. And then you have a real-time visibility into available spaces. So whoever is doing it, the operator will have a camera view on where things are going and where he has to go. And if it is going to the right place, he will have a green alert. Otherwise, he'll have something like a red alert. So he'll have visibility on where he has to go and put stuff. And then there is guided put away using a digital floor map. So we have a what is called a 3D floor map. We'll get to see in the next few slides. So there you have a touch-based interface where people can assign put away locations, the manager can do, and whoever is doing the put away, he'll get to know where the location is, where he has to put it. And then, like I mentioned earlier, there is lots of exceptions that happen. So there will be no barcodes and damaged barcodes and things like that. And we can use OCR for those. And also we can do the put away planning. If it is not planned properly, we can use our AI techniques to plan properly. And for packing also, we have some solutions where we can do item verifications, counting, and those using the camera. So we have some stationary cameras with using depth, and they can do the counting, and they can do the pick and pack real fast. So the digital floor map will help a lot using the guided pickup and put away. So these are the solutions that we have for dynamic product storage. We have pallet tracking, and we have real-time visibility in available spaces with the 3D map, like I mentioned, and people get to have live camera view, guided put away, and we ensure that the pallet is stored at the designated location. If it is going into a wrong location, you will get alerts and notifications. So likewise, item verification, no handheld devices, cameras will do this thing automatically. And the exception handling using OCR like damaged barcodes or stuff, we can use text to do that. This kind of same, we are talking about hazardous materials, how to handle those. So we'll have special instructions on the carton boxes if it is hazardous material hazmat. So we can use our vision techniques to figure out, and we can properly put them in the proper areas. They need to have special handling. So likewise, damaged and bad barcodes can be handled. So overall, these are the benefits. Real-time visibility, put away planning tool we have, so the manager can upfront do the planning. If a truck is going to come in, he'll know upfront and he'll plan where these things can go. So wherever there is a put away that happened, there is automatic capture. The system itself will send an event out to the event broker, and it gets integrated into the warehouse management system. So if there is a FIFO kind of a warehouse, then those things are handled. The perishable goods, if they are there, they have to go first according to the expiry date. So that part is also handled in our algorithms. And then there is AR-enabled warehouse map. So people can pick and choose the available spaces like you do in an airplane. You can pick and choose seats. And yeah, that's another nice and cool feature that we have. So overall, we have it on our tablet interface, where this AR-enabled warehouse map is going to help a lot. So this is the scenario that we are talking about in terms of warehouse automation. Like on the left side top, you can see that a truck has just arrived. So these are the pallets, and the forklift is taking these pallets and it has to put in receiving lanes. So we want to track the pallet movement to these receiving lanes. We want to make sure that things go to the proper place, and we also do the detection part. So for that, we are using AI and cameras. So we detect the pallet and capture the put away location in the receiving lane, right? So in the step 2, if you see, we do the verification of items. So each of the item can be verified. So the tablet has a camera in it, so that can be used for verification. And as part of number 3, once items are verified for that purchase order, now they can go to a bulk storage. Now we know that, okay, we got all the things properly for this purchase order. So now we want to put them in a proper storage. So for that also we use our AI and camera to detect the pallet that needs to be picked up from the receiving line and we want to put it in a storage. Here we are calling it a bulk storage. There we do a what is called put away. So then here also the forklift comes into picture. So we have to do the recognition, detection, and then we do the tracking as well. How we do it, we'll cover in the subsequent slides. So number 4 is similar. Step number 4, from the bulk storage, if we get an order and we need to ship it out to some other customer, so we also track from the bulk storage all the way to the outbound zone, and from there it will go to the truck that is shipping. So here we use our computer vision and AI techniques again. So before we send things out, we do the verification again using the tablet interface. So these are the 5 steps that are of interest. So this is the nice and cool feature that I was mentioning earlier. So if you see, you can see the real-time view in 2 different ways. Like one is the 3D map. So the cartons that are lying, that are showing as the brown color boxes, those are already placed, and the green color ones, those are the places that are available for taking, right? So you can, if the operator has a tablet, he can use the touch interface to pick and choose where these carton boxes should go. The manager will decide, and then those things get saved in the system. And on the right, you will see a live camera view. So whatever zone you pick, that zone has multiple cameras, and those camera views are displayed in the live camera view. So as the forklift comes into that zone and wherever things are placed, you see a live camera view. So this is the example of how we assign. The manager is assigning, let's say 2 carton boxes, 2 pallets have arrived. So those 2 pallets need to go to these locations in inbound 006 and 007. By touching these warehouse map locations, the manager saves in the system that these 2 are the designated ones. So the operator will use them to place the pallets using whatever forklift that he has. So there are different kinds of forklifts. So we use models to detect those. And so once the pallet and the forklift, they reach the proper location, like for example here, IB007 towards the right. So it is displayed on the live camera. So our AI engine sends back events, and the user interface on the tablet will display the boxes around, saying that, okay, this is the right location, IB007, that is the designated put away location. So whoever is using the tablet can see this location on screen and say, okay, this one is done, okay. And then behind the scenes, the backend will send events and the databases get updated. So likewise for pickup, the earlier one is for put away. Now the manager says, when there is an order, these are the pallets that need to go out. And so this is the one that is designated to be picked up. So the operator will use his forklift. Here it's a hand operated forklift. So the operator goes to that location, and if it is the correct location where the pallet is getting picked up, so the AI engine will use the camera feed and make sure that this is the location that is highlighted. So IB007 is the designated pickup location. And this pickup location, if it is a FIFO kind of an algorithm, it will decide upfront that this is the one that needs to be picked up. Right? So this is another feature where we get the pack level details on the floor. So if you touch whichever pallet, you can see that this is the location, this is the SKU, and this is the quantity. And this is a slide that shows how we do our barcode and OCR based item verification. So if you can recall, this is step number 2, where once we get all the pallets, we do item verification. Right? This is also done using cameras. So these cameras pick up whatever barcode is available in this image, and this barcode is processed, and we know that this is the SKU. So there is no human element involved. So let's say the barcode is damaged, or there is a older barcode than currently whatever it is there in the system. Then there is a discrepancy. At that time, our system will use OCR to match stuff. So now this item is verified, saying that, okay, this is matched to whatever it is supposed to be there in the purchase order. Right? So here we are talking about how the integration happens with other systems. Like on the right, you will see a warehouse management system. On the left, you see our WareTrack system. So whenever there is a purchase order, it comes to our WareTrack system. And there we'll do the assignment part, receiving, dispatch, whatever. This assignment, these assigned locations, they go to a message broker. From there, WMS can subscribe to those messages and it will integrate. So likewise, there is messages going back and forth between WareTrack and the warehouse management, so that these two systems will be in sync. So we are saying that we are not replacing a warehouse management system. We are augmenting or complementing warehouse management systems using a artificial intelligence and computer vision based product, which will make things a lot easier. Right? I'll briefly go through the solution architecture. Like here to the left, we have a front end. We have user interface built on top of Android using a tablet. This is used in the warehouse for managers and whoever is the executives that are moving stuff. So this interacts with the backend API, which is done using microservices in Java. And this is deployed on cloud using AWS. So we have a AWS architecture, but for want of time, I'm not getting into deeper details on that. We use lots of AWS managed services, like we use the EC2 instances, and we use Kubernetes. We use EKS and ECR and all those managed services here to do our backend services. And the key element here is what you see on the top. This is what is the heart of the system. This is where we do all our AI, ML, if you will, our computer vision algorithms. They sit here. And here we have multiple choices. We can have things running on an edge server that is deployed on-premise in a warehouse, or for a few warehouses, we can have one nearby location where we have a big edge server that processes all the video that is coming in from the cameras. And all our AI works off of this edge server. But we also have a choice to use an edge server on the cloud. So we also try to use on AWS. And also we used hardware things, servers on the cloud, different ones. And we used CPUs, GPUs, and also what are called VPUs from Intel hardware. So we'll cover a little bit in the next few slides. So this is the AI servers on the top, and at the bottom we show warehouse management systems which we integrate with. So this is in brief the high level architecture. So if you want to have more details, I can give more later on. So here we are getting into the details of how our AI automation is done, what algorithms and techniques we use for this thing to work. So here we are going to talk about two things: image analytics, deep learning. We use both kind of techniques. So for us to get stuff to work, whatever we talked earlier, so we need to do 4 different things. We need to detect the pallet, and then we need to detect the forklift. And number 3, we need to track the pallet, where it is going from which zone to which zone, what's happening. And occupancy analysis is something where we want to know if things are going into the proper location, the zone, wherever things are supposed to be. Like if there is a location inbound, so if it is called IB007, like in the example, so that kind of analysis, if it is occupied or if it is taken, if it is going to the correct. That part is occupancy analysis. So the approach is we can do it in two ways and we do in multiple ways. So here we talk about image analytics. So we use shape and color features for detecting the forklifts. Forklifts, we don't have too many types. So for a particular warehouse, we'll have a few different colors and shapes and stuff. So for that, we use shape and color feature information for us to detect the forklifts, and also for the pallet loads. If they are two different kinds of things, like they don't change all the time, then we can use this shape and color feature. So that's number one that we use for image analytics. Number two, we use what is called Kalman tracking. Perhaps most of you know about it. So on these pallet loads, we use that technique, and you do the tracking until the load is dropped. So that's what we call put away. So the guided put away we do using these kind of tracking techniques. And when the pallet is dropped in a proper put away and pickup information, our AI engine will send events to the event broker, and the subscribers, whatever systems are there like WMS, they'll consume those events and they'll update the database accordingly. So we have a few advantages taking this route. So we were able to get 80 to 90% accuracy. Yep. Sorry, go ahead.
Sir, there is some audio disturbance from your end, sir. Can you please check it once?
Okay, getting 80 to 90% accuracy. So is that fine, sir? No?
Okay, sir. Okay, sir.
Okay. So with whatever deployments we had and trials we did, with the image analytics, whatever we did, we got a reasonable way accuracy, 80 to 90%. And the biggest advantage of taking this route is we can use lesser resources. Like rather than going via other techniques like deep learning, these imaging techniques, they consume lesser resources. But we have some flip side of it. So the disadvantages, we have the accuracy. It is dependent on lighting conditions and how the warehouse is and where the cameras, the heights and how many cameras are there. All these things will come into picture in terms of accuracy. So these conditions play a big part when it comes to imaging techniques. So the other disadvantage is all the time we don't have the same palettes, same loads that come in. We can get different shapes, different colors and those things. So those are some things that may break our system. We may have to go back and do some tweaking, tuning. Right. So this is one technique, and we'll look at the other way of doing pallet detection and tracking. So if you see here, so we can use other techniques like foreground and background segmentation, like whatever you see at the left side, this part. And we also do color segmentation to figure out which one is the pallet, which one is the forklift, and the person and stuff. So this part is the color segmentation techniques. And this is the pallet tracking, the Kalman technique that we use. And these are some other technique for detection and tracking that we use. Okay. So this is the object detection model. Like, so how we use, like, let's say there is a camera, it is looking at all these locations in the floor map. And this is a live camera view. But behind the scenes, how does the AI engine work? So it uses a YOLO V4 object detection model for detecting pallets and forklifts. And we also use what is called SVM classifier for finding out what are all the empty spaces. So this is for our occupancy analysis. But when compared to the imaging techniques, this is highly accurate. So we get 95% accuracy here. Our models are very well trained and they give lots of accuracy. And the other advantage we have here is we can get different loads with different colors, textures and shapes and everything. So we can train our models to do the detection correctly. But this technique also has some flip side, which is like it needs more data for training. So we need to have lots of data to train the model properly for it to work. And number one. Number two is these are bulkier models and they need bigger machines, lots of resources. So the resource utilization is more. So what we do to overcome this resource utilization is we are trying to use what is called OpenVINO framework. This is from Intel. Like I mentioned earlier, we are collaborating with Intel and they are using some techniques and we are also working with them to optimize things that we are doing and we are converting to OpenVINO, and with these models we are getting a processing of up to 28 frames per second, which is very reasonable, and we can use this in production. And we are also working right now to optimize this further. So we are also looking at help in that area, and Intel is helping a lot. So this is how it is done. So this example, whatever we talked earlier, like whatever models we use, they are in work right now. So on the left, you see a forklift that is bringing in 2 pallets, and those are recognized and those are handled properly. So this is a real warehouse, and towards the right, you see a enactment of how things work here. So this is a person that is pulling the pallet, and when it goes to the right place, it is marking it as green. So it is properly placed in IN001. That's where it needs to be. So the color has changed to something else. So the green one, it says it is available, and the okay. All right. So I was trying to fix my microphone to get it better. All right. So yeah, this is a very nice and interesting thing for all the techies here. So this is some benchmark data that we have, that we tried on Intel's hardware. So at the bottom we see this is the sample that we used. So we used a video that is of 1 minute and 10 seconds duration. So which is a 30 FPS. So this is the sample, and we benchmark against different hardware. So at the bottom, if you see, we have these Intel Xeon processors on premise in our location. So we have these 2 models for pallet detection and person detection. And if you see, we are getting 0.35 seconds for a pallet detection and 0.02 person detection, which is kind of okay. But when we go to the different hardware that Intel provides, and we also use the OpenVINO way of doing, and we have the ones that are listed at the top. So if you see, some of them, they gave real good 0.007, like if you use this IDC 024. So this kind of benchmark data we use when we go to production, we'll recommend. So these are the servers that we can deploy on cloud with this particular VPU that they can use. It can be a collection of VPUs, a cluster of VPUs that we can recommend. So based on the warehouse size and based on the requirement, we'll do proper capacity planning, and then we recommend what kind of edge servers that can be used, or whether they can be deployed on cloud. Okay, I'll move on to the next one. So here we talk about data. Yeah, this is a big challenge that we have, like for us to recognize to proper detection and tracking. We need to have proper models, and for us to get there, we need to have massive amounts of images and data, and that's a big challenge. So we use synthesized data alongside whatever data sets we have. So what we do is we use our Unity tool, and we prepare these 3D models and synthetic data, and we write scripts to create those objects and annotation coordinates, and this synthetic data helps us a lot in getting our models into better accuracy. So these are some other examples. If you can see, these are pallets that are stacked up. And this is one bulk storage that has only one level. And this is how you see it from the top. So these are different synthetic data that we use for our system to work. All right. So this is about how we use AI and IoT in handling warehouses, how we do warehouse optimization. We can take a little pause here, or we can move on to the second one. I'll just give a quick pause here if you have any quick question, or otherwise okay. I'll move on to the next one. So this is about how we do the AI-enabled IoT in retail industry. Like you see, there is lots of stacks and racks here with lots of products. So in retail space, there is lots of lost business. Like if you don't have a product, if the customer comes and if it is empty, right? So the customer goes to a different store. So there is something called a planogram compliance. We'll get there. First, I'll talk about the challenges. So customers now, they don't have too much time. They have different channels. They can order online, or they can come to a store. They can use mobile phones. So there is this multi-channel. So they want to have a seamless experience. They order on a cell phone and they come pick up in a store. So this is very rapidly evolving. Yeah, one sec. Bhaskar is saying there's some problem with the phone. Yep. Sorry, folks, about that booming noise. I just put the microphone near my mouth, so Bhaskar alerted. Now I hope things are better. So I'll talk a little bit about the challenges faced in the retail industry. And yeah, so it's a lot about business, right? We don't any retailer, they don't want to lose any business. They want to have customers loyal to them. They want to inspire them. So that is where this planogram compliance and out-of-stock detection comes into picture. So what is planogram compliance? Like, let's say I'm selling a box of cereal, or let's say there is Coca-Cola selling their cans. So they want to have them at a proper height, in a proper location where the customer can see them properly. So there is a specific location where things will go. Like things won't go in a random place in any store. So there is a proper plan. So there is a planogram, that is the image that is given to the store. So from the product vendors, and they have to comply with that. So they cannot put wherever they want. So that is something that they want to track. If they are not placed properly and customers cannot see them properly, they lose their business. So all the product vendors, they want to comply with this planogram. So this is where we help using our deep learning, image processing, and OCR techniques. So we'll compare the features and we'll make sure that it is compliant. If a different product is placed in a wrong place, we'll get alerts. Like you see here a red annotation that's saying that there is a different box. It's not compliant with the planogram. So it will alert for non-compliance. So likewise for out of stock, this is where lots of business is lost. Like if you don't have the item, customer will go away. He'll go to a different place. So empty shelf detection, that is done using shelf cameras, smartphones, tablets, and these cameras. So these are our gadgets. So we use deep learning models for detecting empty shelf areas. And whenever there is an item that goes out of stock, then immediately alert goes and somebody in the store will put back things so that they won't lose. So these two are very critical in terms of retail analytics, and how we do it using our AI and imaging techniques, and that part is covered here. So whenever there is a product, we have to take a 360-degree capture of that particular product, and we have to build a library of all these SKUs. So all the items, they are captured in different angles. There is a 360-degree capture. We have a SKU detection station where we have cameras, turntables, tails and stuff. So we capture all the details there. The dimensions, weights, all of these are automated. And then we have these 6 sides or all sides based on whether it's a box or whether it's a can and stuff like that. We get the UPC code, all the nutritional facts. We get the text, everything we capture, and it will be uploaded to the DSL. And then this is used in planogram development, and this is how it is used in space allocation. And once they are put in store, we'll make sure that the planogram compliance is adhered to using this DSL database. This is the library that is very critical. Right? So this item track works off of a mobile phone. So when we select out of stock and point our cameras towards the shelves, whenever there is something that is detected, where there is things that are out of stock, then it will raise an alert. Like you see, these images are processed using our models, and then the things are alerted. The red one says that things are out of place and things are out of stock. So likewise, the planogram compliance, we have out of stock as well. If things are not there at all, like if wrong items are there, then the planogram compliance works. And if things are not there at all, then we'll show and we'll alert. So it will give a real-time visibility for out of stock. Right? So the department manager and those managers, they'll get a real-time report on what things are out of stock, and they'll replenish them real fast. Right? So these are the benefits. So we have a 360-degree visibility to all aspects, and we can use the current assets to drive sales. So we don't have to install lots of other things. So whatever are the current assets can be used. Right? So we have our own proprietary AI, ML, and vision intelligence techniques, and we use them as a combination to deliver the item track features. Right? So this is how we do out of stock. We use a deep learning model, and we train it with a data set which has lots and lots of retail shelf images. So we have this model that will recognize once they take a picture, they take these pictures periodically and they are uploaded to the AI server, and it will determine all the out of stock things, and we raise an alert, and then they'll replenish right away. So for detecting the objects in the shelves, so we use our own deep learning network. And there is another challenge that we have with these images with high resolution and the higher number of pixel sizes. The images are really huge. So for processing those, we need a lot of resources. So in order to optimize on that resources, what we do is we crop the images. So we crop them to 300 by 300 pixel size. So all these tiny bits and pieces will be sent to the AI engine and processed. So these are annotated accordingly. So this is where we optimize our resource usage, the hardware usage. So these cropped portions are only sent to the model. So that's where we get some better results easily. So this is how it works, like the way I mentioned. On the left, you see the full image of a rack with lots of items. So that image, it won't be processed by itself. So we take bits and pieces out of it, smaller ones, 300 by 300. They'll be passed to our proprietary network, and then it will provide the detections, the annotations, if you will. So they can be color coded accordingly. All right, so these are the results. So whichever are out of place, like you see here, these frosted flakes are the right ones according to the planogram compliance, but there is a different item here, so you see it in red. That is where it is alerted that the planogram compliance is violated. So likewise, you can see things that are out of stock. Right? So we also have this feature where we extract the results. So we detect the objects and we feed the objects through our OCR engine to extract the product related information. Like it will read the image and it will find out what the text is in that, and it will update the database or recognize, detect accordingly. So this is the process that we use for doing the retail analytics for planogram compliance and for out of stock. Number one, we have the item related information. What is the rack number? What is the shelf number and the product location and the product information. And then once we extract the text, we compare with the existing planogram data. And then if that matches, then we look at the next item. If it doesn't match, we'll send out a notification and it will be displayed accordingly. So on the user interface, it is displayed and alerts are sent out, and the user he can go and fix the correct item as per the planogram. Likewise for out of stock, if the AI engine detects any empty space, then we look into the planogram data and where is the user in the retail store will be intimated. This item is out of stock, so please go replenish. So that's how it impacts their business. All right. I think this is all I have to present from our side. So I think we have a few minutes left for any Q&A or anything that we can discuss. So I welcome you all to interact. Thank you. Thank you so much.
Yes, we are very grateful for the time and effort you have taken to share this presentation, sir. And thank you for sharing knowledge, and thank you again for your contribution for today's session. Thank you very much, sir. And Dr. Kumar Swami, sir, will be speaking to you.
Excellent. Thank you so much, ma'am, for the opportunity. Thank you very much, Dr. Kumar Swami, and thanks everyone.
It's indeed our pleasure to have you, sir. You have given insights of how industry people present the case studies, the topic compared to academicians. So we are very much thankful to you, sir, for accepting my invitation and delivering lecture, sir. In future, definitely we need your services in extending the help to the faculty as well as students. Thanks a lot, sir.
You are very welcome, Dr. Kumar Swami. Thank you very much from my side and from
from my side. I'd like to thank even Shrikant Natarajan, sir, who referred you. Through him, I could able to approach you, sir. Thanks a lot for Shrikant, sir, also. And we will definitely make use of you for future workshops.
Excellent, excellent. Thank you so much. Any more details you need, you can reach.
Yeah, definitely. So, any doubts from participants?
No, sir. Okay,
perfect. Yeah, I'll drop off now. Thanks a lot.
Yeah, thanks a lot, sir.
Thank you.
So our next session will start at 2:30 to 3:30. We have next session followed by valedictory from 3:30 to 4:20. So I request all of you to join on time, offline students as well as online participants. All of you please join for 2:30 session followed by valedictory session. And I request our expert to share the content. Thank you.
One more announcement here. We have a test, small test from 2 to 2:30. So it will be of MCQ type. So all are requested to, or I can say it is mandatory for all the participants to attempt that particular quiz. Thank you.
Yeah. So please attempt the quiz MCQs from 2:30 to 3:30 before the session starts. Okay. So the link is link will be shared. Is it already shared, sir? No. Not yet, right? So it will be enabled at 2 o'clock and it will be disabled by 2:30.
But it will be shared in the maybe in another 15 minutes.
Yeah.
But the link will open only at 2 o'clock.
Yeah. And it will be closed by 2:30.
Yeah, it will be closed by 2:30.
Thank you.
Okay, sir. Thank you, sir.
Okay, na?
మోస్ట్ ప్రాబబ్లీ సెమినార్ హాల్ అయితేనే బెటర్.
అక్కడ నుంచి చేసేది
ఎందుకంటే మళ్ళీ అగైన్
కింద పెట్టడం కాదు.
2:30 to 3:30 అంటే 3:30 కి ఇమిడియట్ గా మనం
స్టార్ట్ అవ్వాలి. అది అవుతూ ఉన్నప్పుడే చేసే అరేంజ్మెంట్ చేసేసుకొని ఇన్స్ట్రక్ట్ ది